by adding x to both sides. So then we're going to be left with a negative 2y is greater than or equal to x plus 4. Now we have to remember, when we divide by a negative and it's an inequality, what must we do to the inequality sign? Flip it. So instead of y being greater than or equal to, now it's y is less than or equal to negative a half x minus 2. And now we have it in slope-intercept form. So I'm going to go and get my graph started. My y-intercept is negative 2, and my slope is negative 1 over 2. So that means we're going to rise negative 1, run a positive 2. So if we're going to rise negative 1, it means we're going to go down 1, and then positive 2 is to the right. So we're down 1, right 2, and then up 1, left 2. I'm going to keep going. Up 1, left 2. Go one more. Up 1, left 2. And now I have to decide, when I connect these points, am I going to connect it with a solid line or a dashed line? And how do we know? Good. It's solid because the inequality is less than or equal to. Because of that line underneath the crocodile mouth, we are now connecting this with a solid line. But we're not done. So it's saying y is less than or equal to this line. Now, a lot of you could probably just ration it out in your head, meaning if y is less than or equal to the line, where is y? What y values are less than the line? Wouldn't it all be below the line? So if you could just rationalize your way through it, by all means, go ahead and shade where you know. Let's say you weren't sure. What you can do is you can test a point either below the line or above the line, because we're either going to shade above it or we're going to shade below it. If 0, 0 is an option, I always like to choose 0, 0 to test. So what's going to happen is I'm going to go back to my original. Negative x minus 2y is greater than or equal to 4. And I plug in 0 for x. I plug in 0 for y. And we're going to have, oh, what happened here? Oh, yeah. I went back to the original. 0 minus 0 is greater than or equal to 4. Is 0 greater than or equal to 4? No, this is not true. Since it's not true and the point 0, 0 was above the line, that means I'm not going to shade above the line. I'm going to shade the other direction, which is below the line.
Can I just rationalize that though? Would you? No, I'm just saying, would you?
Rika, how did I start this? I said if you can rationalize it, by all means. If you can't, you can test a point. Rika, it's on video now. Me reprimanding you. Okay, so now what does this mean? This means anything that would be in the shaded region would fit the solution of negative x minus 2y is greater than or equal to 4. Let's pick a point and test to see if we're true. Give me a point that's in the shaded region.
Negative 3.
1, 2, 3, 4. Sure.
Wait,
no. Negative 4, negative 3? Okay, so let's test negative 4, negative 3. So we're going to have the negation of negative 4 minus 2 times negative 3 is greater than or equal to 4. Well, the negation of negative 4 is 4. Negative 2 times a negative 3 is a positive 6. Is 4 plus 6 greater than 4? Yes. Any point in that solution set will hold true here. That's what this is saying. Okay, so now today, we're going to step it up a little bit. We're going to do systems of inequalities with other conics that aren't just lines. But before we do that, I'm going to have you do one more problem on your own. Also, Algebra 1.
Did you pre-order the new two Aftershock books? I pre-ordered them.
I did not pre-order them.
Two more.
Two.
Two. One
I
in
think October.
One in
One in February, January. I am going to see The Devil Wears Prada tonight, though.
I'm going.
Early release.
I took the essay.
Aw, that's a fun reward.
For 4 months studying a 2-hour movie. Yeah.
I think so. It is for your future.
Did you take the SAT?
I took it once. I didn't do phenomenal, but I did okay. And then I didn't take it again, and I didn't study, so it wasn't that bad. I got a 1250, 1240, something like that, with no studying.
Yeah,
But that was good enough for me. I'm like, that's fine. It was the math held me. It was
the math was worse.
no, it held me, meaning I did really good on the math. I almost got perfect on the math, but then my ELA was so bad. But no, when I was taking the SATs, it was all vocab. It was like this word is to this word as this word is to this word. And I'm like, I don't know what any of these words are. It's obscure words, and all four of them are obscure, so you can't make a relationship between any of them. And it's a negative too.
It was words like
The PSAT is like boring. But I'm taking it this Saturday a little bit. Yeah.
Can I see that?
It's a little hard if it's not warm. But
Why does everybody love this?
when it's warm, it's hard.
But why?
It's really nice.
How do you push it back? Like that?
If you just leave it on the basket on the top.
Really? I pushed it back a little bit. I feel like it's a little bit too hard to squish.
It's not. It's still.
Because it was outside, it was cold? Why was it cold outside? Why were you outside with it? But the school's not cold. Is it your turn?
Yeah,
I don't love it.
I don't like the ice cream. I like. It's I like.
Could I see it?
You have to run. Do you have the thing, the one that has the balls in it? No, I have the one that has the fuzzies on it, like the little kind of like frizzies. And keep in mind, it's okay. We can get it nice and easy.
oh, I love the negative feelings. Yeah, I don't care.
Are we ready? You guys want graph paper? Anybody want graph paper? Okay. Yeah, it's sketching.
From others.
It was awkward in all fairness. All right, I think we got to move on, guys. First, you have to put it in slope-intercept form. So we're going to subtract that 2x over. So we have negative y is less than or equal to negative 2x minus 3. When we divide by negative 1, what must we do? Flip the signs. So now we graph. Oh, I forgot to flip this. I said flip it, but I did not flip it. I said it, but didn't flip. Okay. So our y-intercept is 2. Our y-intercept is 3. Our slope is 2 over 1. So up 2 to the right 1, then down 2 left 1. And then we're going down to left 1. I think that's good enough. We'll go one more down to left 1. And it's solid line because it's greater than or equal to. Guys, I can't have the side conversations. It'd be a dashed line. So if there was no line underneath the crocodile mouth, we'd make a dashed line. Okay, so we, Rika, just rationalize that y greater than y, where y is greater than this line would be above the line. That's all where y is greater than. And if you could rationalize it, do you have to test? No. But if you can't rationalize it, you can't visualize that, can you test? Absolutely. So if we're going to test the point 0, 0, we go back to the original and we're going to say 0 minus 0 is less than or equal to negative 3. Is 0 less than or equal to negative 3? No. So this is where 0, 0 is. Since that doesn't hold true, am I going to shade where 0, 0 is or on the other side? The other side. So that means I am shading here. But now this is a system of linear inequalities, which means I'm not done. I have another line to graph. My other line that I have to graph is the equation x is, or inequality, x is less than or equal to negative 2. So I go to where x is negative 2. I draw a solid line through that because of the less than or equal to. And then I ask myself, where are the x values that are less than negative 2? Isn't it to the left? Since it's to the left, let's go green here. It's going to be, actually, highlight, what color should I highlight? Gray. Highlight gray. And my solution is going to be everywhere that's yellow and gray. So my solution set is the overlap of the yellow and gray, which is going to be this area right here. So I will erase it so you could see what the solution is. Oops.
Oh no. It's all gone.
No, it's fine.
No, no. I'm pressing my last.
1, 2. Oh, wait. That was fine. Okay. So that is the area, the gray yellow that I have left over. That's going to be in our solution. That's going to be our solution. So what does that mean? Any point in that shaded region will fulfill the inequality 2x minus y is less than or equal to negative 3. So now that was our nice Algebra 1 recap. Now we're going to do this with nonlinear conics, or a conic with a line. All right. New lesson. No, Maya, we're not talking because I'm teaching. Yeah, conic inequalities. So now we're going to graph baby steps. I work us up to that. X squared plus y squared is less than 16. First thing we're going to ask ourselves, what is this? It's a circle. Is it in the standard form that we want?
Yes.
Yes. So what is my center here? And what is my radius? Perfect. So now I can go and start my sketch. So my center is 0, 0, and I'm going to go 4 to the right, 4 to the left, 4 up, and 4 down. But now when I go to connect these points with the circle, is it going to be dashed or solid? Dashed because there's no line underneath the inequality sign. So we're going to do a dashed circle here. Yep, it's just a sketch, guys. Nothing's going to be perfect in these. It's just a general idea of what it looks like. Now, we need to show the area that's less than. X squared plus y squared is less than 16. So what I'm going to do is I'm going to pick a point. We're either going to be inside the circle or outside the circle. Those are our options for shading. Shade inside the circle or shade outside the circle. I'm going to test a point. I do not want to test the center point. I never want to test a point that's part or helps create the graph in any of these, I always like to choose a point that's not involved in it. In this scenario, 0, 0 would still hold true for us, but I'm trying to choose a point that's not involved in it. So I'm going to pick the point 1, 1. So we go back to our original, and we're 1 squared plus 1 squared is less than 16. Does this hold true? Yes. Isn't the point 1, 1 inside the circle? Since it's inside the circle, that means the whole solution set is every point that's inside the circle. Not so bad, right? Next one. Rectangular hyperbola. I really think so. People don't understand. Yeah, you guys get it. You get how funny I am. My husband tells me I'm not funny, but I really am. Yeah. He's pretty funny though.
What? For gonna say you're not funny and then laugh at everything you do anyways. Yeah, that's just saying.
Okay, so how do I know that this is a rectangular hyperbola and not a line? Lucas? Good, because the x and y are being multiplied together. In a line, they're being added, right? It's a plus or minus between them. Here, because it's multiplication, it has to be a rectangular hyperbola. So I'm going to get it into its format by solving for y. So when I solve for y, it's going to be y is greater than or equal to 4 over x. I just divided by x. And now this absolutely fits the format of y equals a over x minus h plus k. We have to draw the asymptotes. Very good. So do we agree that the center of this rectangular hyperbola is the point 0, 0? And the asymptotes will be x equals 0 and y equals 0? All right, so let's get this graph started. Well, it's the axes, so. Guys, we can't have all the side chatter. Okay, because A is positive, which quadrants are we going into here? 1 and 3. And now what we're going to do to figure out exactly where, so we know we're in 1, we know we're in 3. I'm going to take the square root of A, which is going to be plus or minus 2. What this plus or minus 2 means, I'm going to go from the center point, and I'm going to move 2 units up, down, left, or right to get me in whatever quadrant I need to be in. Since I need to be in quadrant 1, I'm going to move 2 units to the right, but also 2 units up. And then remember, we hug the asymptote. And then to get into quadrant 3, I go from my center, I go 2 units left, but then also 2 units down. And we hug our asymptote. Miss you. All right, so now I drew solid curves because of the greater than or equal to, but now our options for shading. Our options for shading are either going to be inside each curve or between the 2 curves. So our options for shading will be inside each curve or between the 2 curves. So what I'm going to do is test a point in one of the curves. So I'm going to test the point 1, 2, 3, 4, 1, 2. I'm going to test the point 4, 2. So go back to your original. So I'm going to go x, y is greater than or equal to 4. Go back to our original. So if I'm testing the point 4, 2, this is 4 times 2. Is that greater than or equal to 4? Yes, which means I'm shading inside this curve. And by default, I'm going to have to shade inside the other curve. But let's say you didn't trust that, right? Could I test a point inside the other curve also? Sure. Let's go 1, 2, 3, 4. Let's go -4, -4. So then we're going to test x, y is greater than or equal to 4. -4 times a -4, is that greater than or equal to 4? Yes. So then point proven, we shade over here. Just to prove even more, I'm going to pick a point that's not in the graph. I'm going to pick the point -1, 3, just to show you. And so this is going to be xy is greater than or equal to 4. -1 times 3, is that greater than or equal to 4? No. So see, that doesn't work. All right, are we ready to now do a system between conics? It's a little fun. As fun as... All right, let's do this one. X squared plus y squared is greater than or equal to 4. And x squared over 9 plus y squared over 4 is less than or equal to 1. So what shapes are we dealing with? An ellipse and a circle. So let's, since they're already in the right format, I could just get right into sketching. So I have a circle with a radius of 2 and a center of 0, 0. And I'm doing a solid line, a solid circle because of the greater than or equal to. So now for x squared plus y squared is greater than or equal to 4. Are we shading inside the circle or outside the circle? Outside. We're going outside the circle. Let's say you weren't sure. What should we do? Test a point. Let's test a point inside the circle. Let's test the point 1, 1. Is 1 squared plus 1 squared going to be greater than or equal to 4? Never. So that point was inside the circle, which tells me I have to shade outside the circle. I'm not going to shade. Just let's hold off. But just remember, we're going to shade outside the circle. Now let's go to our ellipse. Is this a horizontal ellipse or a vertical ellipse, and how do you know? Horizontal because why? Bigger number under the x. So do we all agree my A is 3, my B is 2, and my center is the point 0, 0? All right. So my center is 0, 0. I'm going 3 to the left from 0, 0. I'm going 3 to the right from 0, 0. And then I'm going to go 2 up and 2 down. So it looks, like I said, this is just a rough sketch. It's not perfect, but it looks something like that. Okay, so now I have to decide, x squared over 9 plus y squared over 4 is less than 1. Let's test the point 1, 1. Is 1/9, what am I testing, 1, 1? Yeah, okay. Is 1/9 plus 1/4 less than or equal to 1? Yeah. So what does this mean? So this holds true. So that means for the circle, I'm shading outside the circle. But for the ellipse, I'm shading inside the ellipse. So now I have to figure out where would they overlap? Where would outside the circle and inside the ellipse overlap? Wouldn't it be right here? So that is my solution set. All right, I'm going to have you try one on your own and then we're done.
like Corella, you're colonists. Nothing much more to show. Just wait. Oh god. So I have to see this a lot. Oh, yeah. There's a hyphen.
It's that hard. No.
I'm all right.
Yes. Yeah, for sure. Yeah, yes. Well, I spell is always going to be negative because you're squaring it. Right.
It's just going to be like an estimate. I would find, like, I would plug in one value for X. Like, I would do like X equals 1 just to find 2 points to help you out a little bit. I'll show you what I mean. All right, guys, let's go over this. Do we agree the first inequality is a circle? So this is going to be X squared, add that Y squared over is less than or equal to 9. So my center of the circle is 0, 0, and my radius is 3. And for this one, guys, what is Y is less than or equal to negative X squared? Well, it is a parabola. Is it opening up or is it opening down? Down. This absolutely fits the format of A times X minus H quantity squared plus K. Do we agree the vertex here is 0, 0? And we're opening down because A is negative. All right, so let's get to sketching. So circle center 0, 0, we're up 3, down 3, right 3, left 3. And now I know I have a parabola with a vertex of 0, 0 that's opening down. It would be really helpful to get 2 more points. So in order to get 2 more points, I'm going to plug in for X and find the corresponding Y. So Y is equal to negative X squared. So if I have X be positive 1, Y is going to be the negation of positive 1 squared, which is just negative 1. So that means I'm going to have the point 1 comma negative 1. And then because of the axis of symmetry, wouldn't I have the point negative 1 right on the other side of that? So just to give us an idea, that's all I would do is figure out those 2 points. And so it's looking something like this. Not completely perfect, but something like that. And now for the circle, go back here. Am I shading inside the circle or outside the circle? Inside the circle. Am I shading inside the parabola or outside the parabola? Inside. So where can I shade that's inside the circle, but also inside the parabola? Right here is our solution set. How many people got that correct? Yay. All right, we are done for today. We're actually done for this unit. Yay us.